Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARHAN bin KAMARUZZAMAN. I am from 4 BEA section 2 stroke 1. I am from Faculty of Technology Electrical and Electronic. The code subject is BEEU 4774 Bachelor Degree Project 2. So my supervisor name is TS Muhammad Hanif bin Cik Hassan. My panel number 1 is Madam Nurul Kausa binti Abdul Majid, and my panel number 2 is Sir Ahmad Idil bin Abdul Rahman. So for the part of the introduction, first thing first is about the go-kart. The go-kart is a small motorized vehicle used especially for the racing. And also the mini vehicle driven by human manually. So the next part is the teleoperation. The teleoperation is the system or machine at a distance. For example, is like mobile robots that can be applied to a whole range of circumstances in which a device or machine is operated by a person from a distance. So next is the introduction about the RC car. The RC car is the miniature model cars or trucks that can be controlled from a distance using a specialized transmitter or remote. So the last one is the IoT. IoT is the system of interrelated, internet connected objects that are able to collect and transfer data over a wireless network without human invention. So there are a few problems that have been found before I started to do this project. So the first one is the remote control car have a constant speed. Means that the latest remote control car right now, it only have the constant speed. The next one is the remote control car also have a specific angle of the steering when turning the wheel. So the next last one is the range of connection. So the remote control car right now, they only have using the Bluetooth or transmitter and receiver. The main objective of doing this project is, first one is to build a functional teleoperation system that can display and control the speed and the steering of the remote control car. For the second one is to develop the system using smartphone and implement the IoT. And the last one is to analyze the range limitation, transmission lag, and the effectiveness of the system. While doing this project, there are a few scopes that have been highlighted. So the first one is I'm doing this project to build a prototype of the system only using the Arduino microcontroller. The next one is this system is implemented to the remote control car and will develop more after the system successfully. Means that I just want to do this project only on the remote control car. After the system is successful, and then we will develop more to the mini go-kart. So the third one is the controlling speed and the steering using the motor driver and connect it with the Arduino microcontroller Blink application. So the last one is the analysis operation limitation, transmission lag based on several weather conditions such as heavy rain. This is the main system flowchart. So first one is we initialize the pin and the library, and then set the servo to the center and motor to the 0 speed. So and then the next one is here, move button in application click. So when we go to the forward button, the motor move forward, and then we want to stop the motor, we just click the stop button, click, and then the motor will stop. It is also same with the backward. When we click the backward button, the motor will move backward, and then the speed slider also can move and also change the motor speed. And then we can stop the button click, and then motor will stop. So that one is for the motor. Okay, the right one is for the servo motor that can control the angle of the servo motor. So this one is the direction angle slider move. So when we move the slider to the left, the servo motor will move to the left, and then if we move the angle slider to the right, the servo motor will move to the right. And then there are a few buttons that can make the direction to the default position, and then the servo motor will move to the center. And there are a few data analysis that have been tested after the project is done. So the first one is the connection of ESP8266 with the Wi-Fi connection. Okay, so we are testing from the range of the ESP and then the time to connect to the Wi-Fi. So and the range 2 meter, time to connect to the Wi-Fi is the 3 seconds, and when the range is 4 meter, time to connect to the Wi-Fi is 5 seconds. It means that the more the range of the ESP to connect to the Wi-Fi, the more the time taken to connect to the Wi-Fi. So the second one is the speed of motor versus time taken for the distance about 20 meter long road. So I have been test at the speed in percentage, and the time taken is also in the same at the second. So for the first test, I put to the 30% of speed, and then the time to complete the 20 meter long road is 26 seconds. When I put to the 100% of speed, and the time taken to complete the 20 meter long road is 11%. 11 seconds. So the next one is the ultrasonic sensor when in reverse mode. So here is the value in blink, and also the range between car and object in cm. So when the car is about 0.1 cm from the detected object, so the value in the blink application is 2. So the test number 4 is when the car is 6 cm from the object, the value in blink application interface is 90. So from the project that have been made, the conclusion is to make the system will be same with the manual car. It's mean that I want to make the system will be the same as the car on the road. So the next one is the after the system is successful, and it will apply it to the mini go-kart that have been noticed at the title of the project. So the last one is I also can achieve the hi, this is my video demonstration for the development of teleoperation of mini go-kart. So this is my blink apps interface. Okay, this is the hardware implementation. It is controlled by the Node MCU and also the motor driver inside. And there's also the servo that can control the steering angle of the control car. Okay, this is the ultrasonic sensor to detect the object when in reverse mode. Okay, so to turn on the control car here, this one, and then play button at the blink apps. Okay, so just move forward. So this one is the forward motor, this one is the reverse of the motor, and this one to stop the motor. So here this is the reverse sensor. The reverse sensor is when the
ultrasonic sensor detected the object, and then the value will pop out here. And this one, the upper slider, is the control of the steering angle of the control car. Okay, this one is the control speed of the car. Okay, this one is the default angle of the steering. If I want to move the car forward, I need to press this button, and the car will move forward. Okay, then if I want to reverse the car, I press this button.